So this is the recording for Friday, 9/13. Just a reminder, we're writing homework 4. That is on the homework sheet on my YOLA site. It's due on Wednesday of next week. We just green penned and turned in homework 3. If you're absent, you can do that the next time you're in class. And we're writing the notes now for 0, 4, nth roots, and real exponents. And so we are going to simplify expressions in radical form. We're going to simplify expressions in exponential form, and our new vocabulary is the nth root and the principal nth root. And so as we look at this, what I'd like to do, because when some people told me that they were going to be gone, immediately I thought, this is a trickier lesson, so I want to make sure that they get as much access to that as possible. So what is going to happen here is we're going to go over a few problems that are familiar to us, and so then we'll do some other things and that are kind of related to the lesson. So I'm going to just start with some things that are super familiar to you. And we've talked about this, just recently. If x squared equals 25, then x equals plus or minus the square root of 25. And some of these square roots we just know by heart. The square root of 25 is 5, correct? But the reason, we want to kind of backtrack a minute to the reason that's the case. And so now I'll just use a different square root. If I have the square root of 36, the real reason that is happening the way it is that is the square root of 6 squared. Does everybody agree with that? And probably the word index is new to you. Maybe not. The index, because have you done the cube root? Just give me a head nod. Have you done the cube root of something and maybe the fourth root of something or other roots? So the index is the number that goes right here, and that tells us what root that is. And when it's a square root, we just don't write any number there. Do you agree? That's just the square root. It's like saying x. We don't say x to the 1, and we don't even say 1x. But those ones are there. We just don't write them as we go. So same thing here. In a way, there could be an index there of a 2 for the square root, but because it's the one that we use most commonly, we don't write that. If I want to write the square root as a fractional exponent, just give me a head nod if you know what the fractional exponent would be. So the fractional exponent for a square root is 1/2. And think about that. If I have 6 squared and I raised it to the 1/2, do you agree that I take a power to a power, I multiply, and 2 times 1/2 is 1? Right? And so I would get the square root of 36 is the square root of 6 squared, or it's 6 squared raised to the 1/2. These are saying the same thing. So maybe this is new to you, or maybe, it's something you haven't had a lot of exposure to, and so then we get 6. We're used to just saying, oh, square root of 36 is 6, right? But we want to think a little bit more about these things, because that'll help us as we move on to maybe more difficult problems as we go. So this whole concept of square root, the principal root, and I didn't say nth right now, but the principal root is when we do this plus or minus square root, the principal square root is the positive square root, okay? Or the principal nth root is generally the positive square root. We'll talk about that a little bit more as we go. So I'm going to just write a very short list of numbers, 1, 2, 3, 4, 5, 6. I'm going to square them. So these will be x squared, 1, 4, 9, 16, 25, 36. And then I'm going to cube them, 1, 8, 27, 64, 1, 25, and I don't know, 6, 3, 18, 216. There we go. And so the square root of 25, 25 is 5 squared, and 36 is 6 squared. So if I want now the cube root of, we'll say 27. I'll just write it right off of this little list I made. So that's that index thing. Maybe you've never called it an index, I don't know. But now does that seem familiar to you? Just give me a little, yeah, I've seen that now. And so the cube root of 27 means what times itself and then times itself again. What times itself again is equal to 27. And so we know that that's equal to 3. And the reason is it's the cube root of 3 square, to the third. Oh, my bad. 3 to the third. And so I have 3 times 3 times 3. This is the cube root. And so that comes out as a 3. There's another thing that we want to be kind of aware of just before we even do this lesson, and that is, what about negatives? So we've already talked about negatives a little bit, and if I have the square root of -9, we agree that that's imaginary, correct? And if you looked at our heading, it says like nth roots and real exponents. So all we have to have is exponents that are real, and we can have complex answers of our solution. We know that if I have to think of this as real numbers, that if it were real numbers, there's no solution. Do you agree? If it's real numbers, there's no solution. If we're allowed to use imaginary numbers, it would be 3i. Does everybody agree? And we've kind of had some problems like that before. So there's no real solution. How about this? The cube root of -216. Give me a head nod. Is there a real solution to that? Is there a real solution to that? Is there a real solution to that? There is a real solution to that. So when we were looking for -9 and the square root, there's nothing that I can take times itself that will give me a negative, right? Because if I put a negative in that parenthesis, negative times a negative is a positive. If I put a positive, positive times a positive is a positive. But if I ask myself what times itself and times itself again is going to give me negative, I can do that, because a negative times a negative times a negative is a negative. So this is the cube root of, as long as I think of that 216, I know it's 6 times 6 times 6. If I think of it as -6 to the third, negative times a negative times a negative gives me a negative. Do you agree with that? And so there's a little extra rule that's happening with negatives. If I have a negative and it's a square root, or I'm even going to go further and say this. If it's a negative in the radical and it's an even root, so this is square root, this is to the third, so this could be the fourth, the fifth, the sixth, the seventh root. If it is an even root and this is a negative, that we can't get a real answer for. But if it's a radical and it's to the odd, has an odd index, then if it's negative, we can still get a negative as we go. And I do have to pause this a moment, but then I'll be right back with this. Okay, now we're writing this nth root of a number, and it's kind of confusing the way it says it. So that's why, I wanted to kind of give us a little forewarning of what's happening here. And so this says, let A and B be real numbers, and let n be any positive integer greater than 1. So if A equals B to the n, then B is the nth root of A. And sometimes that is easier to kind of write in a way with numbers. So you need to write that, because that is going to be kind of the way we want to think about this. So we'll just go 36 equals 6 squared. So that means that 6 is the square root of 36. So if you write it with numbers, maybe that'll help you a little bit understand what that is. They should be in here somewhere. So hopefully I said this right on that last slide. So the principal square root often is the positive square root. Remember that for an even power, it has to be positive. Do you agree with that? The even power, because if we get the square root of negative 36, it's not real anymore. And they are talking about real numbers. So we know we can do that with I, but in this case, when we're talking about this. So when it's an even index, the principal square root has to be positive as we go. But if it's that odd power, and it can be negative, do you agree? So the principal square root, if A has an nth root, then the principal nth root of A is the root having the same sign as A. And the nth root, and it's denoted this way, the nth root of A. And I will ask you to be kind of careful. I wrote that sort of big, but the cube root is like this, the fourth root is like this. Sometimes people write like that, you know, and to me that looks like there's a 4 out in front, and there could be, and it could be the square root, but just be a little cautious how you write those roots as you go. So everything that's in that box you should write. And if you want to write the things that I wrote there as well, you sure can, but they're a little more optional as you're looking at that. Yes. Yeah, and I didn't read all that, so that last sentence people are questioning. Yes, I want you to write that. So the principal nth root of A is denoted as by the radical expression, the nth root of A, where n is the index of the radical and A is the radicand. And again, the higher we get into math, the more we want to maybe write some of those words that are new to us. Yep. So that's kind of what I was writing there. So that's the nth root of A. So it might be like the cube root of whatever number I would put in there or whatever as we go. Does anybody need to see those couple of sentences right there? Okay. If you're waiting, you can kind of look at those little things below with the blue. I'm just going to go over those. You can decide if you're going to write them or not. And I'm just going to remind us, 3 to the 4th is 3 times 3 times 3 times 3. So I'm just reminding you of this because we haven't really written it down yet. But 3 times 3 is 9, and this 3 times 3 is 9. 9 times 9 is 81, or 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 to the 4th is 81. So you have a little context for this next little set of things that we're going to look at here. And so you might want to write this down, or just look at it at very least. So the fourth root of 81 is 3, and that's because 3 times 3 times 3 times 3 is 81. And if the negative is out in front, then you just leave the negative out in front, and the fourth root of 81 is still 3. And if we have the plus or minus fourth root of 81, then that's plus or minus 3. So just kind of some just variations of things that we are aware of. Now, none of those said anything about the fourth root of negative 81. The fourth root of negative 81 would not be a real answer. Do you agree? Because we can't take something times itself 4 times. If it's negative, it'll turn positive. If it's positive, it'll stay positive, and we couldn't get a negative 81. Now, this next thing is something that I expect you to know as well. Sometimes it's a little hard to exactly know what a table is saying or until we kind of actually do problems with it as we go. So we're going to talk about even and odd things as we go. And so this is the nth root of real numbers. I don't know where, it doesn't really have this anywhere on here. Well, it has it in a couple places, but this is talking about the nth root of A. So A is the number that you're putting in there. And so it says, suppose that n is an integer greater than 1 and A is a real number. So if n is even, then here are things that happen as we go down, or if n is odd. So if n is even, think about going down here. This is like the square root or the fourth root of something, and a is kind of in there. Those are things you're familiar with. So if a is greater than 0, there can be one positive and one negative real root that we can get. If a is less than 0, there's no real root, right? So in this case, it would be like the square root of negative 16, and that's not a real root. Oh, I wrote 16, but it kind of went together. And I'm trying to use some perfect squares just to kind of get a good sense. It could have been 6, right? And so it's same thing would happen. But that's not a real answer. And then, of course, this one just says, you know, since it was greater than or less than, if it's the even root of 0, it's always just going to be 0. So the big difference is if it's odd, we always get an answer, right? If it's even, this one is not real. But if it's odd, then we can get that as we go. So this is maybe the third root of A, or the seventh root of A, as we look at that. And so one positive and one negative real root for this one, and 0 positive and 1 negative real root if a is less than 0. So if it's the cube root of negative 27, then we just get negative 3 for that one. Yep. I would like you to write something about that table. Yes, you should be writing this table as we go. So I'll give you a moment or two to do that. Now, one of the reasons it's critical to kind of remember this is not only so that you know if there's not a real answer or if there's exactly one, but we deal with variables a lot, correct? And so when we're taking, instead of, being -16 or -27 or +36 or something like that, if we have a variable under the radical, then we have to kind of think about whether these things are going to work or not. And so especially when it's an even index, there's something in particular that we have to be aware of. And I personally call it like to me, it's the even, odd rule. And it only is with variables. So, but if it has an even index and an even power, and the result is an odd power, we have to put absolute value over it. And I'll talk more about that later, but if you think about it, if it's an even power, remember that can't be negative in there. So if we get an odd power answer of x, like we'll say x to the third is our answer, well, x to the third, if it's could be negative or positive, and we'd get a value. But if it's negative, then we can't do that even root as we go through. And so we will have to occasionally put some answers in absolute value. And I'll go over that a little bit later, but it has to do with these, that sometimes there's not a real answer. Now, the next thing that I kind of like to do personally, and I ask that you do, is I'm going to write a little table with some values. We'll call them A. And then I'm going to do a squared, a to the third, and a to the fourth. But a to the third and a to the fourth, I only go to 6. And the rest I go to 12. So I'm going to make it's kind of a long table. A is going to be 1 to 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And then a squared, I'm going to do all of those. But then I'm going to make a to the third and a to the fourth. Those I'm only going to go to 6, just because they get really big and then it's hard to quite know. And just this process of writing those kind of just puts in your head what are some perfect squares, perfect cubes, perfect fourth power numbers as we go. So we're just squaring each of those. This is 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. So those are the ones that we want to try to be able to recognize, and definitely the squared ones, most of us are going to recognize those. Really, even squaring up to 15, like 225 is 15 squared and things like that. And then cubes, we're really just multiplying these two together. So 1 times 1 times 1 is 1, 2 times 2 times 2, 2 times 2 is 4, times 2 is 8. This is another exception. A lot of times we want to know 2 to higher powers, but right now this is 27, that's 64, 125, and 216, I think is what we said there. Just so that you're kind of seeing those. So if you come across one of these numbers, it might jog your memory that, oh, that's some perfect power as I go through. And then just to the fourth, 1, 8 times 2 is 16, 27 times 3 is 81, 64 times 4 is 256. I have these written down. This one, 5 to the third is 625. Oops, 625. So just so that we kind of recognize some of those, 216 times 6 is 1296. And I will just put a little arrow here because I'm just going to say 2 to higher powers is often used. And I really do count on my fingers a little bit when I do that. So I'll say 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 2 to the 6th is 64. Do you agree with me? Okay, so that's what I use my fingers for as I'm getting higher powers of things. So in my mind, it will just help you. I will often be writing these in exponential form as well. So like I'll just circle this 1296. That's really 3 or 6 to the 4th. Do you agree with that? 6 to the 4th is the 1296. That's what we're having as we go there. Okay, now the next thing we want to do is we want to look at some problems and kind of thinking about this little table as we go. So here's our first problem. Now, look at that. The negative is outside, correct? So it just means the answer is negative. So that's all we have to do. What's the square root of 49? Just tell me. 7, so it's negative 7. That one's just negative 7. Now, the cube root of this one, do you remember? Yes, these you should be writing down. I'm sorry. And I have them written there. I will start writing the actual problems as well. I'll just write 1b over here. So I want the cube root of 64 over 27. Just a reminder, and like radicals that we've done before, that's the same as the cube root of 64 over the cube root of 27. And really, they're on our table, right? But I am going to write them in exponential form. So this is the cube root of 64 is what to the what power? Off of our table. Oh, and it's several places. So yeah, I'm going to actually go back to that table. So we want the cube root. So even though 64 appears on there twice, where is it? Here and here, we want the cube root. So I want to think of it as what right now? 4 to the 3rd. Does that make sense? Question? Okay, so the question is, can you type that in your calculator? Let me get rid of some of these circles first. Okay. Listen carefully to my answer. Absolutely. However, if all you do is type those in your calculator, you can get those first 3 answers, but we're going to very quickly move to variables. And so I want you to be doing this, sort of without a calculator. And I say sort of because, you might sit there and multiply or divide by like 4s, you know what I mean, to get things. But if all you do is punch it in the calculator and get the answer, you're going to have a super hard time when we get to just variables. Do you know what I mean by that? So, so please bear with me. And if you want me to show you that, I'm not interested in showing you that right now because I want to make sure that we're going through this so that when we go to variables, you are capable of doing it. So the 64 that I want is 4 to the 3rd. Do you agree with that? Okay, and then the cube root of 27 is what to the what? 3 to the 3rd. I should redo this problem later. So the cube root of 4 to the 3rd is just what? 4. I'll just write it here. And the cube root of 3 to the 3rd is 3. So it's 4/3. I'm going to back up here, and I'm just going to remind you that if we've made that a 2, 2 to the what is 64? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 2 to the what? 6. 2 to the 6th, and this is the cube root of 3 to the 3rd. Do you agree that that is actually the prime factorization? You with me on that? That's the prime factorization because 2 is prime. That was not. We can get that same answer here. I want you to process that in your mind because I think this is 2 squared over 3. It's still the same answer. Figure out how I'm getting that on this bottom one because you know the answer. What am I doing? What can I do you think? If I write the prime factorization of this, how can I use that index and that power to get that? It's 6 divided by 3, isn't it? So think about applying that to all of these. If I took 3 divided by 3 there, I would get 1, right? And that's how I get that 3. 3 divided by 3, I'd get 1, so that was 4, so it's 4 to the 1. 3 divided by 3 is 1. But if I went down to the prime factorization, 6 divided by 3 is 2. Give me a head nod if that makes sense to you, because that's a critical kind of little bridge we want to make as we go. And do you agree also that I could say that's the cube root of 2 to the third times 2 to the third? I could do it like that, and then pull this one out as a 2 and this one out as a 2, so that'll be 2 times 2, and it's still 4 for just that numerator part, right? So there's a lot of things that we can use to approach this as we go. So letter C is the fourth root of negative 121. What is it? No. Right. It's not possible, and it's the fourth root, so 11 squared is 121. So but it is not a real root. No real root. You just are writing that there's no real root. And I want you to write this down too. Even index, and then we'll write that radical of a negative is not real. The even index of a negative inside that radical is not real. I should write is not real. Okay, we're going to stack chairs. Have a great weekend. Just a minute.